Hello to everyone. I am Professor Raja, working as Assistant Professor, EC Department, SNS College of Technology, and Autonomous Institution Coimbatore. In this YouTube video, I am going to discuss 1990 T204 microcontroller and embedded system subject under the topic 8051 microcontroller functional block diagram. Based on my previous video, you may have some knowledge about how an 8086 microprocessor is working and how it is interfaced with various components such as 8255, 8279 and 8251. Now we are going to see the microcontroller. The only difference between microprocessor and a microcontroller is the microprocessor doesn't have any storage memory, whereas microcontroller will have a little space of memory. In general, the microcontroller 8051 is a 8-bit CPU with register A and B, internal ROM, that is read-only memory, 16-bit program counter and data pointer, internal RAM of 128 bytes, 8-bit program status word, 2 16-bit counters and timers, 4 8-bit ports, 3 internal interrupts and 2 external interrupts, control register and oscillator and control clock circuits. So these are the various components or some of the features of 8051. This is the general block diagram of 8051. Now we will see individually one by one. The difference between 8051 and 8086 is 8086 have two separate parts, whereas 8051 have so many individual parts. Here we see an oscillator is a separate part, the memory area is a separate part, the port input output latch is a separate part, the arithmetic logic unit is a separate part, and the stack pointer is also the separate part. A and B, the CPU register. The 8051 contains 34 general purpose or working registers. Two of these registers are A and B. The immediate result is stored in the accumulator register A for next operation. The B register is a register just for multiplication and division operation, which requires more register spaces for product of multiplication and the quotient and the remainder of the division. Program status word. The program status word as shown in the next figure. The program status word contains the main flags or the mathematic flags, user program flag F0 and the register select bits that identify which of the 4 general purpose register bank is currently in use by the program. The mathematical flag includes carry C, auxiliary carry AC, overflow OV and the parity P. Program status word. The tabular column look like this: CY, AC, P0, RS1, RS0, OV are called as the program status word. Here CY is the carry flag, AC is the auxiliary carry flag, F0 is the flag 0 available to the user for general purpose, RS1 registered bank selected bit 0, RS0 registered bank select bit 0, OV, it is the overflow flag. Whenever we have go for some mathematical addition or subtraction or division or multiplication, some overflow value will come. That time this overflow flag is used. Hyphen, it is used for user defined flag. At the last P, P is for parity flag. It is set and cleared by hardware each instruction cycle to indicate as odd or even number of 1 bits in the accumulator. 8051 oscillator and clock. The 8051 records an external oscillator circuits where this oscillator circuit will not available in the 8086 microprocessor. The oscillator circuit usually runs around 12 MHz. The crystal generates 12 million pulses in 1 second. A mission cycle is minimum amount time must taken by the simplest mission instruction. An 8051 mission cycle consists of 12 crystal pulses or clock cycle. The first 6 clock pulses is used to fetch the opcode and the second 6 pulses are used to perform operation on the operands in the ALU. This gives an effective mission cycle rate at 1 MIBS, that is million instruction per second. This figure shows how an oscillator circuit and timings are used. So in this YouTube video, I am discussed the internal architecture of 8051. In that 8051, we see program status word, program counter, and some basics of the oscillator circuit. Remaining parts I will discuss on the next YouTube video. Thank you.